In this lesson, we're going to look at a different ratio. We're going to look at the sine ratio. So the first thing to do is to have a look at these triangles in orange here. Now we can see that every triangle's got an angle of 53 degrees on it. But slightly different to last time is that we've got the opposite side here, which is 4 centimetres. But we now have a different side, which is called the hypotenuse. So the ratio we're going to use is slightly different here. We're using the opposite side and the hypotenuse side. And we have to try and find a relationship between these two, instead of the opposite and adjacent for tan. So as long as all the triangles have got 53 degrees on them, if we divide the opposite side by the hypotenuse side, we can see what happens. So if we do 4 divided by 5, then 0.8 pops out. Another triangle with 53 degrees on it, if I take 8 and divide it by 10, I get 0.8. And another triangle here with 53 degrees, if you measure the opposite and the hypotenuse and divide them again, you get 0.8. And basically any triangle with an angle of 53 degrees in it, if you measured accurately the opposite side and the hypotenuse and divided them, then you would get roughly 0.8, depending on how accurate you were. Now again, 0.8 has a special name here. Instead of being the tan of 53 degrees, we call this the sine of 53 degrees because we're not using the same ratio as last time. We're doing opposite and hypotenuse. Again, this works with any triangle between 0 and 89 degrees. If you divide the opposite and the hypotenuse, you will get the same answer as long as the angle and the triangles are exactly the same. And if you're using your calculator just now, if you type in sine 53, you should get roughly 0.8. So the sine ratio is got a formula just like the tangent ratio. If we take the sine of an angle A, and as long as we label it properly, then it's opposite divided by hypotenuse, which can be shortened to sine A's op over hyp. And again, we can do this with every triangle. From 0 to 89 really degrees, we can work out the sine of the value. Right, so let's have a look at an actual triangle and do a calculation with it. So calculating the opposite side using sine, and again I've wrote SAW here, SOH, to remind us of the formula. Sine is opposite over hypotenuse. So as before, draw the triangle out first and label the sides. So we've got the hypotenuse here that was just given, which is 12. That's diagonally opposite the right angle. We've got x here, the unknown, the thing we're trying to find, and that's diagonally opposite the angle here, so that's called the opposite. And the other side's the adjacent. So using the sine formula, sine of q is equal to opposite over hypotenuse. So we'll write that out. We can then, as before, fill in the information. So we've got 20 degrees here for Q. The opposite is the unknown, what we're trying to find, so we'll put that up here. And the hypotenuse is 12, which we will put down here. So if I substitute that in, I'll get sine 20 is x over 12. And as before, if I multiply the 12 by the sine 20, I'm going to get x. So if I just do that here, sine of 20 in brackets multiplied by 12, you'll get an answer of 4.1042, and if you round that accurately, it should go to 4.1 centimetres. So it's very similar to the format we did for tan, except we're using a slightly different formula at the start. Now I'm just briefly going to look at a more kind of complicated example, if you like. Calculating the opposite side on this triangle here. Now this triangle is an isosceles triangle. An isosceles triangle is a triangle with two sides exactly the same. The reason I know it's an isosceles triangle is because if I look at these wee bits here, that signifies that these two lengths are exactly the same. Now the problem here is that we've been looking at triangles that are right angled. So what I have to do here is create a right angled triangle. Now the easiest way to create a right angled triangle is to use either a vertical or a horizontal line. So I'm going to do that here. I'll just make this a slightly different colour and I'll make it dotted. I'm going to split the triangle down here like that. So if I split the triangle there, I create a right angle triangle. I can work out the height, which is what I'm trying to do. H here, I'm trying to work out this. I've got a 7 along here, and basically that's all I need. So I'll draw that wee right angle triangle out and label it. So my 7, my H, my opposite, hypotenuse and adjacent. And this is the information I'm going to use in my formula. So it's the sine of 35. We don't have a letter here, so just sine 35 is equal to opposite over hypotenuse. Again, I can sub in the opposite as h, and the hypotenuse is 7, so I'll do that just now. And then just multiply sine 35 by 7. Make sure you put the 35 in brackets to stop the calculator multiplying 35 by 7 first and then doing the sine of that. Type that in correctly, make sure you're in degrees mode, and you'll get an answer like this, which is just 4 meters. So this triangle is 4 meters high.